this is Dr. Rajiv. Welcome to the greedy algorithm lectures. Today we will discuss what is the meaning of greedy algorithm. A greedy algorithm is a process that looks for simple and easy to implement solutions for multi-step complex problems. And in these algorithms, at each step, uh, our algorithm will find that value which gives the most obvious benefits. Generally, greedy algorithms are used for optimization problem. There are certain problem sets which are solved via greedy approach, like fractional knapsack problem to find the minimum spanning tree using Kruskal algorithm, to find the minimum spanning tree using Prim's algorithm, to find the shortest path algorithm, like Dijkstra's, Floyd's, etc. Greedy algorithms cannot be applied to all the problems. Like fractional knapsack problem can be solved by a greedy approach, but 0-1 knapsack cannot be solved by a greedy approach. Then why these are called as greedy? Because greedy algorithms build a solution by choosing the optimal solution for smaller instance or subproblem. Mean it it gets the best solution for a subproblem without considering the future aspect. That's why we can say that while choosing the solution for these instances, it does not consider larger problem as a whole. It may be possible that earlier selected solution may not be a part of the final optimal solution. That's all. We will continue the greedy approach in next lecture. Thank you. Hi, this is Dr. Rajiv. This is in continuation of our last lecture about greedy algorithms. Today we will discuss what is the meaning of greedy approach, optimization problem, feasible solutions, optimal solution. So formally greedy algorithms we can say are for solving the optimization problem. A optimization problem is a problem in which we require minimum or maximum results. Algorithm go through a sequence of steps with a set of choices at each step. Algorithm tries to optimize the outcomes based on the sequence of operation. Characteristic of greedy algorithm is that it makes the choice that looks best at the moment. Mean at every step it is choosing the best without considering the future aspect. It may be possible that the choice which you have chosen at this point may be left at a later stage. It does not guarantee for global optimization solution, but it makes a locally optimal choice with the hope that it will lead to the global optimal solution. So there are certain points related to the greedy approach. The first one is that greedy approach is designed to achieve optimal solution of a given problem. In greedy approach, decisions are made from the given solution domain. That is, we have given a set. Out of this set, we are choosing the one. And while using the approach, we consider the nearest optimal solution and then move on to the next step. Most of the problems in greedy contains n number of inputs, and our objective is to find a subset which satisfy our constraint, and this subset finally when we have the set That is called as a feasible solution. We are required to find a feasible solution that either maximize or minimize a given function, and out of these feasible solutions we find the optimal solution. There can be more than one feasible solution, but the value of the optimal solution should be unique. This was all about greedy approach. In the next lecture, we will take the job sequencing. Thank you. Hi, this is Dr. Rajiv. Today we are discussing job sequencing. Let's define what is the meaning of job sequencing. We are given n jobs. Each job, say I, has a deadline di, which is greater than or equal to 0, and a profit is associated with this job I. This profit is strictly greater than 0. If the job is finished before the deadline, then this profit is earned. Now in the problem, we have to maximize the total profit if only one job can be scheduled at a time. These are the constraints. That is, for job I, profit Pi is earned if and only if the job is completed by its deadline. Now here the meaning of if and only if means it's a both way. Means if we say Pi is earned, means the job I was finished by its deadline. The second way is if the job is finished via its deadline, then automatically profit PY is earned. So that's why this is if and only if. It is also given that every job takes single unit of time. Mean whenever we process our job, it would take only 1 unit of time. So the minimal possible deadline for any job is 1. To complete a job, one has to process the job on one machine for 1 unit of time. Only one machine is available for processing jobs. So if we sum up the constraints, we can say we have one machine and we are to process one job at a time on that machine, and in 1 unit of time job is finished, and profit would be earned only if the job is finished by its deadline. So what is the meaning of feasible solution here? It is a subset J of jobs such that each job in this subset can be completed via its deadline. Value of feasible solution J is the sum of the profits of the job present in J. So here symbolically we can say summation I belongs to capital J, which is a subset, and sum of all PIs which are there in subset J. Let's have one example. Here number of jobs 4, n is equal to 4, and P1, P2, P3, P4 gives the profits of these jobs. That is, for job 1, profit P1 is there. For job 2, profit 2 is P2 is there. So correspondingly, we have 100, 10, 15, 27. Similarly, we have the deadlines for each and every job. D1 is a deadline for job 1, it's 2. D2 is a deadline for job 1, it's 1. D3 is a deadline for job 3, it's 2. And D4 is a deadline for job 4. So feasible solutions can be, now this is the data set, or here we have serial number 1, we have 1, we have the jobs 1 and 2. But let's see what is the meaning of this processing sequence. Here the processing sequence is given as 2 and 1. Why so? Let's have the sequence in the previous slide. because the job 1 and 2 are selected and the deadlines for job 1 is 2 and the deadline for job 2 is 1. That's why the processing sequence is 2 and 1. Mean if we have the processing sequence as 1 and 2, if we have the processing sequence as 1 and 2, see, if we the deadline for 2 is 1. So when we finish job 1, there is there will be no scope to execute job 2 because its deadline was 1. That's why the job processing sequence for jobs 1 and 2 is 2 and 1. And the earned value is a sum of profits. Here the profits, when we select job 1 and 2, profit is 110. 100 for job 1 and 10 for job 2. Let's see this job 1 3. Now job 1 3, if we select job 1 and 3, the deadlines for job 1 and 3 are 2 and 2. So there is no conflict whether to take first job first or third job first. So that's why we have both way. Sequence 1 and 3 can be there, sequence 3 and 1 can be there. In any case, the profit will be 115. At sequence number 3, we have jobs 1 4 and the processing sequence is 4 1. Why so? Because one for the deadline for 1 and 4 is 2 and 1. Again 2 and 1. The deadline with the job with deadline 1 is taken first and the job with deadline 2 is taken second. So we have 4 and 1. Overall profit is 127. So in this way we can explain each and everything. Similarly, let's have a look at sequence number 6. At sequence number 6 we have a job single job 1 because this is also a feasible solution and here we are getting a profit of 100. When we take single job 2, profit is 10, sequence is 2 only. Then third value is 15 and when we take single job 4 and profit is 27. Solution 2 4 or sequence 2 4 cannot be a feasible solution because job 2 and 4 deadline is 1 only. So we cannot execute both jobs when their deadlines is 1. We cannot process these two jobs simultaneously. Deadline DI means job I should be completed by a DI time. This is a greedy algorithm. At step number 1, sort all jobs as per the decreasing order of the profit. Now we are executing steps A and B for each and every job which is there. Find a time slot I if the slot is empty and I is less than deadline. I is greatest, then put the job in this slot and mark this slot as used. If no such job I exist, then discard the job. Let's explain this algorithm with the example. Again, taking the same example which we have discussed in the earlier part of the lecture. So we have 4 profits 1 4 3 2. This is the sorted order of those profits. So job 1 is added, j is equal to 1. It is a feasible solution. Now job 4 is added, 1 4. Whether it is a feasible or not? Yes, because the deadline of 4 and 1, deadline of 4 and 1 1 and 4. Deadline of 4 and 1 is 1 and 2. Deadline of 4 and 1 is 1 and 2. Yes. Job 3 is added. Job j is equal to 143. But it's not a feasible solution because what is the deadline of 3? Deadline of 3 is 2. So already up to 2 we have taken the job 1 and 4. So J3 cannot be added to the solution set. Now when we add J2 the solution set, let's see whether it is a feasible solution or not. No, because deadline of 2 is also within 1 and 2. So it is, we have to discard this job. So final solution is 1 4 and the profit value earned is 127. I hope you can have the idea about the job sequencing with this example. Thank you. This is Dr. Rajiv. Today we are discussing activity selection, which is an important problem in design and analysis of algorithm. Let's define what is a activity selection problem. So we are given an activities. We can call it as jobs also. So each of these activities having its own start time SI and finish times FI. Now the point is to select the maximum number of non-conflicting activities to perform within a given time frame. Further, we are assuming that these selected activities can be performed by a single person who shall work on a single activity at a time. The activity selection problem is also known as a interval scheduling maximization problem. For example, single room is given and we are to schedule number of different classes in that single room, and each class is having its own start time and finish time. Now let's define what is the meaning of non-conflicting activities. Two activities I and J are said to be non-conflicting activities if Si is greater than or equal to Fj, or Sj is greater than or equal to Fi. That is, the start time of first job is greater than or equal to finish time of second job, or start time of second job is greater than or equal to finish time of first job, where Si and Fi and Sj and Fj denote the starting and finishing time of I and J activities respectively. The target is to maximize the count of the selected activities for execution. Here the greedy approach is used. Via this approach, the activity with earliest finish time is selected and move on to the second job and so on, thus yielding the optimal solution. Let's discuss the algorithm. At step number 1, the activities are arranged in ascending order as per their finish time. It means the job with smallest finish time comes at position first and so on. Now let's have one variable select underscore act. So the first activity is taken from array A and it is stored in select underscore act. And there is one another array solution in which we will have the final solution. Now step 4 and 5 are repeated till we don't we go through all the activities which are present in array A. Now we check if the start time of the select underscore act, which is the currently selected activity, is greater than or equal to the finish time of the pre underscore select underscore act. Mean this is a previously selected activity. If this is true, then add it to the solution array. Else reject. At step number 5, we update the select underscore act. Here we take the next activity in A. So step 4 and 5 are repeatedly executed. Then at step 6, solution array is printed. Let's discuss the previously discussed algorithm with the example. Now on this slide we have two data values, one on left side and other on right side. The data values on left side is the original data given. Here we have six jobs named as J1, J2, J3, J4, J5, J6 and so on, and each and every job is having its start time and finish time. Like J1 job is having start time as 4 and finish time as 8. On the right hand side, all these jobs are selected, then sorted as per the increasing order of finish time. That's why job 2 is having a finish time which is smallest among these. So J2 is coming at position number 1, then followed by a J3 and so on. Now let's explain the algorithm on this slide. Now initially J2 is taken and it is added to the solution set. Then J3 is added, selected, and then we are to check whether it is to be added or not. Because the start time of J3 is greater than the finish time of J2. So J3 is added. Now next job in the array A is J4. But the start time of J4 is less than finish time of J3. So J4 is not added. Then next job in array A is taken, which is J5. Here the start time of J5 is greater than the finish time of J3. It means this is true. So J5 is added. That A, J2, J3 and J5 in solution set. Similarly, J1 is not added because its start time is less than the finish time of J5. J6 is added because its start time is greater than the finish time of earlier selected job J5. So finally, the solution set is J2, J3, J5 and J6. This was all about activity selection. Thank, thank you.